Everyone, welcome back to SAT Math Question of the Day. Here's our question. Please try it. Pause the video, come back, and we'll do it. Which expression is equivalent to the sum for all x greater than 3? Oh, wait a second. Wait a second. Those fractions have the same denominator. So they can be added.
Yes.
They can be added. They can be added. And something tells you that when you add them, I bet x plus 7 is going to be a factor. I would not be surprised if x plus 7, because you just add them. They have a common denominator. So it's x plus 7 on top of x squared plus 5x minus 14. But you really should try to factor this, just in case.
Well, okay. Now, let's examine that possibility.
Yeah.
If it's not the case, then the answer would be A or B. But the answer is not A, because A is 1/2 of the expression. It's not equal to the expression.
Then who's giving it? It's not. It's not the expression.
Wait. Why not?
Wait. What?
Why is expression A not equal to the blue expression that you wrote?
Because the denominators aren't the same. And the numerator, they're not identical. They're not identical.
No, you're not complete. The denominator is not the same.
And the numerator
is the same.
No, I said they're not identical. When I say they, I mean all of them. I say they are not identical.
Okay, so we eliminated A. Now what about B? They're also not the same.
They are not identical either.
Why? Because the denominator is the same, and the numerator is not the same.
Yeah, but they're just who has to even process that in the brain? They're not the same. Although they look like they're the same, right? Your brain may deceive you. Yeah, no. You're working. You're getting nervous. You're on a test. You're hungry.
Yeah.
You may recognize it. So these are not the same. Which means that it really looks like you have to factor this.
Yeah.
So without you, pretty clear that it's going to be this answer just because of the negative sign. So we're going to have to factor this thing. So
okay.
Yeah.
So this expression is the same.
Yeah, but who cares? Who cares?
So if you watch to our audience members, if you don't apply simplification and equivalence, the circled expression really is different from the blue expression below. If you didn't know algebra, you would see that these are obviously different. This is different from this, and it's different from this. But because of algebra, they are the same.
Look, come on. We got to answer the question. And these are obviously not the same as this. So who cares?
Okay. So a key thing in this subject is, what does sameness mean?
Fine. Yeah, the sameness. Okay, let's not get so pedantic. Let's factor this thing and see what happens. But we know it's going to be this because of the negative sign. So this is almost certainly going to factor x plus 7. It's like a no-brainer, right? I mean, come on. Of course there's going to be an x plus 7 here. So what is this? Well, in order to get a 14, and this is a 7, this has to be a 2. But we have to make sure the signs... The sign. No, I didn't put the sign yet. That has to be a 2. Yeah. Now we have to get the sign correct. The only way this sign can be correct here is you have to put a minus sign here. That's the only way you're going to get this, because you have a plus 7 minus 2 is a plus 5. So it's this. But you could have also, once you eliminated these, you could have noticed because of this minus sign here, the factor is going to have to be a minus 2. So, all right. Yeah. Right. Yeah. But yeah.
Okay, good.
So, of course.
So, what is the main idea of this problem?
That's right. We've been doing this since August 19th, approximately, of 2022. Yeah. And I think now we're going to start bringing in a new thing called what is the main idea of this thing? Why is this important? Because when you're doing math, when you're doing a lot of problems, you want to just get straight to the heart and say, what is the main idea of the problem? Well, the main idea is algebraic manipulation of fractions and simplifying. How do you simplify fractional expressions? What do you have to do? What do you have to do to simplify fractions and fractional expressions? You have to find out if there are common factors in the denominator and the numerator, and they cross out. And when they cross out, you're left with the simplest possible fraction you can have. Simplify polynomial expressions. That's right. That's the main idea. That's what's really being asked here. When they designed the question, they probably said, well, how can we test who knows how to simplify polynomial expressions? Yeah. So, and of course, that doesn't look like a calculator would be any helpful here. We always try to answer that question too. Calculators that you would get on the SAT would be useless here. And the other question we always ask is, do you do this problem any differently than what you would do if your question was on a normal test in school? And most tests in school are not multiple choice. So you wouldn't necessarily be so lucky to be told that the final answer is this. So you would just have to plow through it.
I think our presentation did illustrate more efficient ways to approach it than the procedures taught at school.
Right. Yeah. Well, normally but if you were taught at school, you normally wouldn't be told the answer. They would simply say, "What is this?"
Yeah.
Yeah. And then you wouldn't. But yeah, you could take advantage of the pattern here that there's a negative sign here, and when you factor it, you're almost guaranteed that the x plus 7s will cancel. Because it's the only way you would get something as simple as C or D, which are the only possible answers after you exclude A and B. So, yeah. Multiple choice questions are generally done differently if you want to do them fast. Done differently from regular questions.
Well, I'd say that the way this differs from the procedures taught at school is that we proceeded to eliminate choices by observing that the choice was not equal to the given. In school, the usual procedure is for taking an expression and calculating another expression that is equal to it.
Yeah.
So what the shortcut is to more quickly figure out that an answer expression is not equal to a given expression.
Right. Yeah, and so slightly different. You would take a different approach. So you want to be cognizant of that when you study for the SAT, because you want to do things fast. You want to do things as fast as possible, particularly on the questions that you can do very quickly. Yeah. To allow time.
Well,
for the questions.
I think generally it's from a calculational point of view, one might expect. And it's often the case in these simple math problems that discovering that two expressions are not equal is easier than proving that two expressions are equal.
Right. The other thing you also a skill you do need, not necessarily the main idea, because this is just a tool that you use to help you with the main idea, is that you have to know how to factor things like this. So I think you in this case, yeah, I guess you do. You do know
that factoring comes at the bottom.
What do you mean at the bottom?
Yeah, well, after you've eliminated A and B, then you need to apply some of the features of factoring.
Right, and that's a skill
And
set.
then even then, you could eliminate the full action of factoring by distinguishing between whether the sign of the constant is negative or positive, because you found one factor. See, by the SAT principle that at least that one of the choices is correct, that tells you that the denominator is factorable.
Yeah.
And x minus 7 is one of the factors.
That's right.
And so your job is to distinguish. Your job, the SAT tells you that there are only two possibilities. Right. They tell you that the other factor, right, the structure of the SAT informs you that the other factor is one of x minus 2 or x plus 2.
Right.
So you need to distinguish which one is the correct factor.
That's right. That's right.
And the quick way to discover that is that, x plus 7 times x question mark 2, because the product is negative.
Yeah.
The question mark must be negative.
Absolutely. Yeah.
So you don't even have to think that 7 times 2 is 14.
No, but you do have to know.
You just have to think that this is negative implies that question mark is negative, and so you pick the one with the negative there.
Getting back to basics, you certainly have to know how to deal with this. So let's just end with, hopefully we'll just quickly go, what does this mean? X plus 7 times x minus 2. What does that mean? That means that x multiplies x and x minus 2, and then 7, and then you add, then 7, then you have to add the sum of 7 times x and 7 times negative 2. That's what this means. It's a double distribution. It means x times
that's
x
what it means.
2
that's what it means.
7 times x.
That's what it means. But the efficient thing is to work only with 1/4 of what it means.
Of course. Yes. Because the constant term, the last term, is always going to be these two things multiplied by each other. These two. Oh.
Yeah.
These two things. Yeah. And this is really an important pattern to be aware of. This thing times this thing. The whole sign, by the way, the whole sign. The whole plus 7 times the whole minus 2. That's going to be the last term of these things.
Well, I mean, we'll also point out that there's another approach. The other approach, there's a second rationale for picking minus 2. What's that?
What?
The plus 5.
Right, yeah, the plus 5. The
plus 5 is well, you have the 7, the plus 7.
Yep.
Plus something.
Right.
Well, the only something that can be added to 7 to give plus 5 is minus 2.
Right.
Okay, so rationale number 2 is that minus 2 is the number such that 7 plus minus 2 equals 5. That's rationale 2.
That's right.
Separate rationale that Joel gave is that minus 14.
You don't have to repeat it. It's fine. We did it. Okay. Okay, we're done. Okay.
All right, so let's
Yeah,
do
let's
the
see.
let's observe.
Let's see what they do.
Let's see if they agree with us, and
Well,
then
yeah,
observe
right.
and
Okay.
take
Uh,
our say
yeah,
and
and
let's
then
rip into with our criticism
yeah, hopefully constructive
their
criticism.
explanation.
Hopefully, can notice it's only 4 steps, so it's not too bad. Since the denominators are equal, we can add the numerators. When we factor the denominator, we get the expression. So they do it the regular way. They don't take any shortcuts. Let's cancel the common factors. That's important. That's the whole idea of simplifying. They don't mention the word simplify. They don't mention the goal is to simplify a rational expression. That's interesting. They just say, let's cancel out common factors. Like, why do that? What's the motivation for even doing this at all? Yeah, why even bother? I mean, this is the answer. So they don't really mention why you have to do this, because the whole point of the question is to simplify. Too bad. They should say like motivation, because this is an answer. It's fine. That's an answer. And x can't be 3? Wonder why x. Anyway, they said x can't be 3. Okay. Anyway, you can avoid the whole search for factoring. What?
Whole search for factoring.
Yeah. Go back to after our starts. Okay.
You don't have to bother factoring.
No, you don't.
To answer this question.
Because they give you the answer. They've already factored it essentially. So, but why
they don't tell you? They don't review how to factor.
No, of course not. But why is it not equal to 3? Why does it have to be x is greater than? What's that about, Seth? You have a PhD in math. We'll talk about that in a second. Why do they make the restriction that x has to be greater than equal to 3?
So that it can't be 2.
So
and it can't be -7.
Oh, okay. Well, why can't they just say x can't be 7 or negative 7 or 2? But that may be giving it away. Oh, yeah. Right. That can't be giving. Right. That they don't want to give it away. Oh, I see. They see 3 because. Okay. Wait. X minus 2 is 2, and x plus 3 is negative 3. Okay. Fine. Okay.
Yeah.
Okay. So I think it's we're done, right?
Right.
Okay. Yeah. Hey, everyone. Let's introduce ourselves. This is Seth. He has a PhD in math from MIT. Been teaching Professor Emeritus for a while, but now retired. No, he's been teaching computer science for a while. Now he's retired. Professor Emeritus. I'm Seth's brother, Joel. I have a PhD in mechanical engineering. We have different approaches to doing SAT problems. We're here to offer our approaches, our thoughts as to how to do SAT problems, and also what's behind the question. That's an important consideration. What's the main point of the question? And to study, go to Khan Academy. They have plenty of problems to work on to strengthen your skills. If you want to strengthen your good skills, you're on the topics that's great. If you're best, it's also important to strengthen the skills that you're not as strong on. And they offer hundreds of questions. Oh, no. I don't know what's going on there. I have no idea, but we're done anyway. You know what it is? I pushed the tiny little thing. I clicked this on my stylus, and all of a sudden the world blew up. So, lesson to be learned. Don't click things on your stylus unless you know what they do. I don't know what this thing does. Did. So, obviously it changed the screen.
You're still there. Your world didn't blow up.
Oh, no, but the screen stopped. But it just, I see. We opened up a Microsoft Whiteboard. So you click this thing, Microsoft Whiteboard opens up. I don't know. Anyway, where were we? Yeah. And then when you're done practicing on Khan, because those questions are sanctioned by the SAT, because now the test is made up of questions that you basically, math that you learn in school, then you go to take as many SAT practice tests as you can on the SAT website. I think we're done. And if you have any...
thank you.
Yeah, please like us, dislike us, please give us comments. And if you have any SAT math questions you'd like us to do, please email them to us at satmathquestionoftheday@gmail.com, and I promise I won't be pushing this little thing anymore. Okay, everyone, I guess that's it for today. Take care. And tomorrow's Throwback Thursday already. Wow, where we do a question from Khan, and then we do a question from about 25 years ago. Bye-bye, everyone.